In this question, we want to determine the vector and Cartesian equation of the plane with the points shown. Well, the direction vectors of the plane can be obtained by determining the vector between any 2 points on the plane. And if we have non-collinear vectors, then that means we have 2 non-collinear direction vectors which satisfy the condition of a vector equation of the plane, and then we can cross them and get a normal, which will help us to determine the Cartesian equation. So if A and B are both points on the plane, then we can say that the vector AB, which is -3 minus 5, 8 minus 1, and 7 minus -2, is a vector on the plane. In other words, -8, 7, 9 is a vector on the plane. Well, multiplying through by -1 so that we have a positive x component gives us 8, -7, -9 as a vector on the plane. Another vector on the plane can be determined by the vector from A to C. And that vector is -6 minus 5, comma, -5 minus 1, comma, -5 minus -2. In other words, -11, -6, -3. Multiplying through by -1 gives us 11, 6, 3. And so one possible vector equation of the plane is 5, 1, -2 plus s times 8, -7, -9 plus t times 11, 6, 3. Well, that's a valid vector equation. We could have used any of these as position vectors. But what we want to do next is find a valid Cartesian equation. And to do that, we want to get the normal vector of the plane. And that's easy to do because we have both of the we have 2 non-collinear direction vectors. So determining the cross product of these 2 non-collinear direction vectors is going to give us a normal. Doing that, getting the cross product, we see is 33, -123, 125. So we can say that 33x minus 123y plus 125z plus d is equal to 0. All we have to do now is sub in any point on the plane. So we can choose 5, 1, -2 and plug in those values. Doing that gives a d value of 208, which means the Cartesian equation of the plane is 33x minus 123y plus 125z plus 208 equals 0.